Right, so Assalamualaikum warahmatullahi wabarakatuh. And good. Tak nak cakap good evening lah. Good afternoon. Rasa macam siang. Beda mah RM2. Sabar je lah. Tak apa. Aduh. Right, so for those who haven't keyed in the attendance, please key in the attendance now. So I'll wait for another 1 minute and then we are going to start. How's everyone? Are you guys doing good? Petang-petang? Okay. Good. Good to hear that. Okay, so basically this is a new chapter. So we have finished chapter 1, chapter 2, chapter 3. So this is basically chapter 4, matrices and system of linear equations. New chapter. So let us go straight away to the lecture. Okay, so there are a few subtopics in chapter 4. So firstly, in the first hour, we got to learn about the types of matrices and then how to calculate the determinant of matrices. And then for the third hour, how to calculate the inverse matrix. And then for the last hour, it will be the system of linear equation with 3 variables. Apa Syairah? RM2 kat Amlan. RM2. Panggil madam. Okay, next. At the end of the lesson, you should be able to, so today we are going to learn 4.1 matrices. So you should be able to identify different type of matrices and then perform operation on matrices. So you've got to know how to do addition, subtraction, scalar multiplication, and then of course multiplication of two matrices. And then find the transpose of a matrix. Okay, so this data are represented in row and column in a rectangular array known as matrix. So we got some row over here. These are the row and these are the column. So we can actually call them as matrix. Okay, so what is a matrix? So matrix is a rectangular arrangement of numbers in rows and column. So where are the rows and column? Okay, so rows and columns. So for example, over here, so this is row 1. Then below here, this is row 2. So that means if we are talking about rows, we have 2 rows. So this is first column. So C1, can I simply write down C1? C1, and then this is C2, so the second column. And then going down this way, so this is the third column. Okay, so we got 2 rows and 3 columns. So now the order of a matrix is the number of rows and columns. So in this case, the order of this matrix is 2 by 3. So this one we simply read them as by, so 2 by 3, 2 rows and 3 columns. And then the entries are the number in the matrix denoted by Aij. So for example, A13. So the first digit referring to the row, the second digit referring to the column. So in this case, we are referring to the first row and third column. So first row, third column. So that is how we get 3. So if let's say you want 7, so 7 is actually in the first row, second column. So the way we write them is A, 1, 2. So this is actually equal to 7. So those are known as the entries. So we got 6 entries over there. Okay, so now types of matrices. So firstly, the row matrix is a 1 by n matrix which has only one row. So it should be straight like that. So A11, A12, A13 up until A1n. So we only have one. So 1, 1, 1, and 1. So this is one row. So for example, 1, 2, 3, 4, 5 or 1, 0, 7, 8, 4, 3, 5. So those are the row matrix. Of course, if we have a row matrix, we also have a column matrix. So column matrix is m by 1, a matrix that only has one column. So for example, this one, A11, A21, A31, and so on. As you can see, the second number that is always 1. So that means this is only one column. So this is first row, second row, third row, and up until the m row. So the example for this, so you might have something like 0, -4. Macam delay sekejap. Okay, tak apa. A, 0, -4, and another one, B, 2, 3, 5, 7. So this is also a column matrix. Okay, next. A square matrix is a n by n matrix which has the same number of rows and column. Okay, so a square, as you can see, this is n, this is also n. So we have the same number of rows and column. So you might have something like a 2 by 2 matrix, or a 3 by 3 matrix, or a 4 by 4 matrix. So we got a similar number of rows and column. So we got to call them as a square matrix. So square, square. Right, so now zero matrix is a m by n matrix whose entries or elements are all zeros and denoted by a bit O. Okay, so this is a 2 by 2 matrix, but every element are zeros. So this is a 3 by 3 matrix, and again all the elements are 0. So this is a 3 by 2 matrix, again all the elements are simply zeros. So that is why we simply wrote down a big O for them. Okay, so now the leading diagonal. Okay, so if let's say A is from A11, A12, A13 until A1M, until AMM. So this is a square matrix. And M by M square matrix, then the leading diagonal are A11, A22, A33 up until AMM. Okay, so what do we see over here? This is 1, this is also 1. This is 2, this is 2. This is 3, this is also 3. And then we got M and M. So where is the leading diagonal? A11 is over here. A12, A22 is over here. A33 up until AMM. So this is something that we call the diagonal. And those are the leading diagonal. So leading diagonal, kawasan diagonal lah. Okay, done. Okay, so a square matrix which non-leading diagonal entries are all 0 is called a diagonal matrix. Okay, so now where is the leading diagonal? So the leading diagonal is 2 and 3. So other than 2 and 3, everything else is 0. So that is why we're going to call them a diagonal matrix. Okay, so B, the diagonal matrix is 1, 2, 3. Other than the diagonal matrix, everything else is 0. So this is also a diagonal matrix. So now the leading diagonal is A0B. So other than the leading diagonal, everything else is 0. Okay, so now 6. Identity matrix. Identity matrix is a diagonal matrix where all its diagonal entries are 1 and denoted by I. Okay, so for example, this one, as you can see, your leading diagonal, these are 1 and everything else is 0. So this is I 2 by 2. What does I 2 by 2 means is that this is an identity matrix, so that is why we wrote down I. A 2 by 2, that means we definitely need to have 2 rows and 2 columns. So that is what it means by I 2 by 2. Okay, so this one, the leading diagonal, everything is 1. Everything else is 0. So this is I 3 by 3. So identity matrix 3 by 3. 3 rows and 3 columns. Okay, so now lower triangular matrix is a square matrix whose element above the leading diagonal are zeros. Okay, so for example over here, so the leading diagonal is 1, 2, 3. So above the leading diagonal are all zeros. So this is lower triangular matrix. Another one, so A, B, F, C, D, E, those represent a triangle. And then above them, this is everything 0. So this is a lower triangular matrix. Of course, if we have lower, we do have something called the upper triangular matrix. So almost similar, except that now all elements below the leading diagonal are zeros. So tadi dekat atas, so sekarang kat bawah lah. Okay, so those are upper triangular matrix. So now, operation on matrices. So we have a few operation that we need to know how to do. So yang tadi tu macam baca je lah. So this is the real part. Addition and subtraction without the S actually. Addition and subtraction of matrices for m by n matrix. So if A is Aij, B is BBJ, so A plus B is equal to C, so C is Cij, m by n, where Cij is actually Aij plus with Bij. If we have A minus B equal to D, so Dij is simply equal to Aij minus Bij. Okay, so what do we mean is that we're gonna add if the two elements are in the same position. So if let's say this is C11, so that means this is A11 plus with B11. So kedudukan dia kena sama, baru kita akan tambah lah. So this is D11, so that means A11 minus with B11. So it should be in the same place. So what do I mean is that, for example, you have 1, 0, 2, 3 plus with 2, 3, 4, 5. Okay, so the way we add them is that A11, so that means this position, you need to add with this position in order for it to be here. So 1 plus 2, so this is 3. 0 plus 3, so this is 3. 2 plus 4, so this is 6. 3 plus 5, so this is 8. So that is what we mean over here. Okay, so now the addition or subtraction of two matrices with different order is not defined. We say that the two matrices are incompatible. So dia mesti kena sama order, baru kita boleh tambah ataupun tolak. Sebab kalau dia tak sama order, nanti elemen dia takkan sama kedudukan tu. Sebab tu kita tak boleh tambah ataupun tolak. Okay, so do make sure the order are similar first before you add or subtract them. Okay, so now example 9, simplify the given quantity for A, 1, 2, 3, 4, B is 4, 3, negative 5, 6. Okay, so now you got to know how to do A plus B and A minus B. So I already showed you one example previously, so I'll give you around 2 minutes for you to calculate the A and the B. So please calculate A plus B and please calculate A minus B, and then we are going to discuss the answer afterwards. So tolong kira dulu lah. Dapat apa jawapan dia. Kalau dah dapat jawapan, boleh tulis Kalau dah dapat jawapan, nanti kita boleh check jawapan sama-sama. Dapat dah ke? Tak tahu macam mana nak type in chat box. You tulis bracket pun boleh kalau nak. Buat bracket and then asingkan macam 2, 3, 4, 5. Boleh lah sebab hasil dia akan jadi 2 by 2 kan. Ataupun nombor, space, nombor, koma pun tak apa. Five, -2, 10. So those are A plus B. A minus B. Okay, so let us check for A plus B. Okay, so A plus B, 1, 2, 3, 4, 4, 3, -5, 6. Okay, so of course in the same position we should add them. So it will be 1 plus 4, 2 plus 3, 3 plus negative 5, 4 plus 6. So it will be 5, 5, negative 2, 10. So betul lah. So let us go to the next one, A minus B. So 1, 2, 3, 4 minus 4, 3, negative 5, 6. So minus 1 minus 4, 2 minus 3, 3 minus minus 5, 4 minus 6, and then simplify them. It should become negative 3, negative 1, 8, negative 2. So kalau dapat jawapan yang betul, lagi sekali tanya. Okay, done. Next. Okay, so now scalar multiplication. If C is a scalar and we have a matrix A, then CA is equal to Bij, where Bij is Cij. So if we times with some scalar, so each element in that matrix should be times with the scalar. So that means if let's say we have A 1453 and B 3642, and then we need to calculate 3A minus with 2B. So do make sure every element in A, you times them with 3 first, and then every element in B, you times them with 2, and then we minus. Okay, so we got to do it one by one. So untuk A, setiap satu elemen darab dengan 3. Untuk B, setiap satu elemen darab dengan 2. And then we minus them. Okay, so I'll give you another 2 minutes for you to solve this. So 2 minit. Cuba try. Dapat apa jawapan? Oh, dah dapat lah. Okay, so now let us check then. Okay, so we got 3A minus with 2B. 3 times with 1453 minus with 2 times 3642. So times with the number first before you subtract. So it will become 3, 12, 15, 9 minus 6, 12, 8, 4. So we simply times them first and then we minus. So it will become negative 3, 0, 7, 5. So dah 2 orang dapat jawapan yang betul. I'm sure yang lain pun dapat jawapan yang sama kan? Okay, tanya. Okay, next. Done with scalar multiplication. So now, a few properties that we have to know. So if we have A plus B, that is actually equal to B plus A. So this is actually called commutative. So that means you can simply change A plus B to become B plus A. And then if we have A plus B plus C, so that is similar to A plus B plus C. So you can either do A plus with B first, or you can do B plus with C first. So this is associative. And then if we have A plus with negative A, this is actually equal to negative A plus with A, and that is actually equal to 0 or 0 matrix. And then if let's say alpha and beta is some constant, so alpha plus beta times with a matrix A, so that is actually equal to alpha A plus with beta A. So it's like expansion. So if we have alpha times with A plus with B, so you can actually expand them to become alpha A plus with alpha B. If we have alpha times with beta A, so you can actually times the constant first, so alpha beta, and then we times them with A. So those are simply the properties. Okay, so now multiplication of matrices. So the product of two matrices A and B is defined only when the number of column in A is equal to the number of rows in B. So you got to see them after this. If the order of A is m by n and the order of B is n by p, then AB has order m by p. So the number of column in A, so this is n. The number of rows in B, so this is n. So that is why you can actually times them, because we have the same number of column in A and the same number of rows in B. Or if we refer to the diagram, if let's say you have A m by n, B n by p, so the product is AB actually m by p. A similar number, you times them, so that is how you get m by p. So those two numbers must be equal before we can actually times them, otherwise we cannot times. Okay, so the order of the product is m by p. Okay, so now a row and a column must have the same number of entries in order to be multiplied. So that is why we say if this is n, this is also n. So it must be the same number so that we can actually multiply them. So multiplication of two matrices, the way we multiply is that we're going to take the row, multiply with the column. So that is the reason why you should match the number of rows and column. Okay, so for example, over here, A1, we got to times down with B1. And then A2 times with B2. A3 times with B3. And then AN times with BN. So you simply add everything, times everything, and add everything together. So kita akan darab, lepas tambah lah. Okay, so now, example 11. So find 1, 2, 3, negative 2, 0, 5, 2, 1, negative 3, 4, 2, 1. So you should times them. So the way we times is that we're going to take the row, multiply with column. So row multiply with column. If you cannot easily see how to times the row and the column, it might be useful if you can actually separate them using a table. So this is for the row. So this is 1, 2, 3. Negative 2, 0, 5. For the column, simply take this one as the column. So this is 2, negative 3, 2. And then 1, 4, 1. So in order to times them, so we're going to take this row times with this column. So 1 times 2 plus 2 times negative 3 plus 3 times 2. So this one is 2 plus 2 times negative 3 plus with 3 times with 2. So for example, over here, this is negative 2 times 1, 0 times 4, 5 times 1. So 2 times them, and then you can get the product after this. Okay, so saya bagi masa untuk awak simplify dia. Another 2 or 3 minutes. 2 minutes, I think 2 minutes will be fine. So 2 times them. So kalau tak nampak, mesti saya tulis clear sikit. So 1, 2, 3, negative 2, 0, 5. So those are the rows. The column 2, -3, 2, 1, 4, 1. So you times them and then add everything together. So times and then add. If you have done them, you can simply write down done and then I'll show you the final answer. Dua, 12, 6, 3. What about others? Do you get the same answer with her? Dua, 12, 6, 3. First time ni nampak nama Khairina naik ni. Okay, so now let us check then. Since some of you already have the answer, so let us check. Okay, so we should times the row with the column. So it will be 1 times 2, 2 times -3 plus 3 times 2. And then first row, second column. So 1 times 1, 2 times 4, 3 times 1. -2 times 2, 0 times -3, 5 times 2. And then second row, second column. So -2 times 1, 0 times 4, 5 times 1. So simplify them. So we will get 2, 12, 6, 3. So betul lah. Okay, so tanya semua orang. Okay, done. Right, so second Sample 12. So A is -1, 2, 3, and 4. B is 2, -1, 3, and 2. So we got to show that AB is not equal to BA. So on the left hand side, we will calculate AB first. So do calculate AB and find out what is the value for AB. And then you calculate what is the value for BA. Once you get the value for AB and BA, you can directly see whether those value are similar or not. So kalau sama, kita letak sama. Kalau tak sama, kita letak simbol tak sama lah. Obviously, we got to show they are not equal. So definitely we get different answer. So firstly, calculate AB first. So calculating AB. So -1 times 2. -1, 2, 3, 4 times with 2, -1, 3, and 2. So you times them. So AB is 4, 5, 18, 5. So this is AB, and then do calculate BA. So 2, -1, 3, 2, -1, 2, 3, 4. So times, it will become -5, 0, 3, 14. So this is AB. This is BA. As you can see, both of them are not equal. We don't have any equal number for each of them. So this is 4, this is -5, 5, 0, 18, 3, 5, 14. So semua tak sama pun. Kalau ada sama satu pun tak boleh. Dia semua kena sama. Baru kita boleh equal. Okay, so they are definitely not equal. Hence we can say that AB is not equal to BA. So this result proves that matrix multiplication is not commutative. So you got to be very careful whether are you multiplying AB or are you multiplying BA? Is it B times A or is it A times B? Because they are not equal. So be extra careful with matrix multiplication because you have to check very carefully. Is it A times B or B times A? So kena hati-hati extra sikit lah. Okay, so done with matrix multiplication, I think. So these are a few properties of matrix multiplication. So if A, B, C, and D be matrices for which the following product are defined, then if let's say we have A times with B times C, so you can actually do A times B first before you times them with C. So this is associative properties. And then A times with B plus C, so you can actually distribute them, or you can actually sometimes it seems like expand. So A times B plus with A times C. So be extra careful. As you can see, A is over here. So that is why A is always in front. So A times B, A times B, A times C. So AB, AC. Be extra careful. You cannot write down BA or CA. Since you times A in front, so A should always be in front. Okay, so now one more thing called the transpose matrix. Okay, so transpose matrix A is written as A with a T. So this is a matrix obtained by interchanging the rows and columns of A. So that means the I column of A transpose is actually the I row of A for all the I. Okay, so if A is M by N, so that means A transpose is N by M. So we're going to change the row to column, column to row. So that is why instead of M by N, we are having N by M. Okay, so for example, this is A. So A11, A12, A13 until A31, A32, A33. So when we transpose them, so instead of having a row with A11, A12, A13, I change it to a column. A11, A12, A13. So change from row to column. And then take the second row, A21, A22, A23 to become the second column. And then A31, A32, A33. So that one will become the third column. So change from row to column. Row to column. Okay, next. Properties of the transpose matrix. So there are a few properties that we need to know. So the first one, if let's say you have A plus minus with B and then you transpose them. So what do we mean over here is that we are going to add or subtract them first before applying transpose. So that is actually equal to A transpose plus minus B transpose. So you can either add them first before you transpose, or you can actually transpose them before you add them. The second properties is saying that if we have A transpose and then you take the transpose of that, that is actually equal to A. So you can actually revert them back to the first matrix. So if you have AB and then you transpose, so this one be extra careful. AB transpose, this is actually equal to B transpose A transpose. So we got to change the place a little bit. So instead of A transpose B transpose, it will become B transpose A transpose. And of course, this is not equal to A transpose B transpose. So dia tak boleh macam suka-suka konon-konon macam apply power ke, tak boleh lah. Okay, so now if let's say you have K A transpose, so that is actually equal to K and then A transpose. So you can either times with the scalar first before you transpose, or you can transpose the matrix before you times with the scalar. Okay, so now let us go to the example. Like B be a 3 by 1 matrix 2, 1, 3. Then the B transpose is actually 2, 1, 3, where we are having a 1 by 3 matrix. So instead of having 3 rows and 1 column, so this is row, column. So instead of 3 rows and 1 column, so once we transpose, we are changing them to become 1 row and 3 column. So that is what we mean by transpose, change from row to column. Okay, so if we have D 1, 3, 3, 2, 5, 4, 1, 3, 5, if you transpose them, so from the first row, you transpose them to become the first column. So 1, 3, 3, 1, 3, 3. Second row, 2, 5, 4. So it will become the second column. And then the third row, 1, 3, 5. So that is where the third column is, 1, 3, 5. So this is the transpose. Okay, so now almost at the end. So now A is 1, 2, 3, 4, B is 3, 4, 2, 1, C is 1, 4, 3, 2. So now you got to show that A plus B transpose is equal to A transpose B transpose, and then BC transpose is equal to C transpose B transpose. So do calculate them, one on the left, one on the right, before you can show them. So for this one, calculate A plus B first. Once you calculate A plus B, then you transpose. For this one, transpose them first before you add them. This one times them first before transpose. This one transpose first before it times. So I'll give you around 5 minutes for you to try to do this example, and then let us discuss later on. Dia sepatutnya kena sama. So try to show that you will get the same value on the left hand side and right hand side. So 5 minit untuk awak try. Kalau ada benda yang tak faham, boleh tulis kat komen komen chat. Boleh tulis kat chat box kalau ada benda yang tak faham. Hari ni dia macam simple sikit sebab kita hanya belajar tambah, tolak, darab je dulu. So for the next class, it will be something quite new because we have to calculate the minor cofactor and the determinant. So this one is mostly, you can say that it's quite a recap. Macam kita tengah recap apa yang kita belajar dulu masa high school level kan. So this is actually a recap before we start with a bigger matrix. So this is only 2 by 2. So after this we're gonna work with a 3 by 3 matrix. So ini macam baru recap lah. Baru macam nak panaskan enjin. Sebab macam dah lama tak pernah tengok matrix kan. Matrices is actually quite a simple topic, except that you really need to be very careful when you are dealing with matrices, because for each step you have to be very careful and keep on focusing about the sign. So sign tu kena bagi fokus banyak sikit lah. Focus more on the sign. Is it a positive or a negative? Sometimes don't make those silly mistake yang macam tukar sign ke apa ke, tak boleh lah. In matrices, you have to be very, very careful. Okay, so 1 more minute and then I'll give the solution. Oh, dah dapat jawapan dah. 4565. So that is actually for the first one, I think. Okay, so now let us go to A. Okay, so show that A plus B transpose is equal to A transpose B transpose. So firstly, let us add the A and the B first. So what we have is 4655, and then you transpose them. So it will become 4565. So this is A plus B transpose. So now for this one, we got to transpose each of them before we add them. Okay, so A transpose. So 1324 plus with B transpose, so 3241. And then you add them. So it will become 4565. So now, as you can see, these two are the same. They are the same value. Hence, we can show that A plus B transpose is actually equal to A transpose plus with B transpose. So, sama lah. Nilai dia kita dapat sama. Okay, so now for B. So BC transpose is equal to C transpose B transpose. Okay, so B times with C first before you transpose them. So B times C, and again row times with column. So one by one, be very careful with the rows and the column. So it will become 3 plus 12, 12 plus 8, 2 plus 3, 8 plus 2. So now make sure to simplify the element inside the bracket before you transpose them. So 15, 25, 10. So 15, 5, 20, 10. So that is BC transpose. So now let us calculate C transpose B transpose. So transpose them first before you times. Okay, so it will become 1, 3, 4, 2, 3, 2, 4, 1. So now we will times them. So take the row times with the column. So 1 times 3, 3 times 4. 1 times 2, 3 times 1, and so on. So we will have 3 plus 12, 2 plus 3, 12 plus 8, 8 plus 2. So we will have 15, 5, 20, 10. So we actually have something the same. Actually, both of them are similar, same. So that means we can actually show, or we can actually prove that BC transpose is actually equal to C transpose B transpose. So shown. Siap. Okay, so I think that's the last question, I think. No more. Okay, so that is the last one. Alright, so that means we are done for lecture 1. So I'll see you guys tomorrow night. So we are going to have lecture 2 tomorrow night. So we are going to start at 9 p.m. tomorrow. So esok start pukul 9 malam semua orang. So I'll see you guys tomorrow. So bye-bye. Bye everyone. Have a nice day.